Hello. We have decided to use this prototyping board because with this it is easy to actually take components away or remove some parts as we are doing the measurements, because usually to do some correct measurements it will be difficult to use our normal board, PCB board, because everything is fixed. So sometimes when we want to test the rectifier diodes alone without the filter capacitor, it means we have to take filter capacitor out, but here we can't do it. Here everything is just placed on the proto board. It means vero board actually. So it means here we can take some things away if we want to do the measurements, and that's what we are going to do here. But this circuit and this circuit, they are exactly the same. You see we are tapping transformer from that side, and now its input is here. That circuit that you see there, the 4 diodes, you see the 4 diodes here. You see the big filter capacitor, it's here, it's the same here. The voltage regulators, they are here. Their capacitors are here as well. The diodes are here, the resistors are here. So these two circuits are basically the same thing. Only that on this side it will be easy for us to remove some components while doing measurement. Now, we have tapped again the input signal, and as you can see on our oscilloscope, again it's the same signal as what we had initially, because it's the signal that is coming from the transformer output. That is the first thing that we have here. Now I want you to look carefully. I have taken away the connection, the output of the rectifier diodes that goes to connect with the filter capacitor, and the entire output is off because it's not connected. Why? Because I want to test the output of rectifier diodes before putting filter capacitor to smoothen. And I want you to see now, because now what we have is only pulsating DC, DC that has ripples, DC which is only unipolar, it's only on the positive half. Take a look. As I mentioned previously, we have signal only on the positive side. We have signal only on the positive side. Why? Because we only have rectifier diodes in action here. The filter capacitor is taken out of the way. You see the connection between filter capacitor and the output of rectifier is not there. As you can see, there is no link here. So that is why you see this is now pulsating DC signal. Pulsating DC signal. This is pulsating DC signal. Pulsating DC signal. As you can see now, we have filter capacitor back in place. As you can see now, the connection is here. There is a red cable or a red wire connecting the output of rectifier diodes to the positive side of the filter capacitor. So filtration is now happening. Let's go and see what we have. Look at the oscilloscope. Something interesting and magnificent. You see now, rather than those half cycles that are clipped on the positive side, as you can see now, we have something that is closer to a straight line, but is not really straight line. As you can see the lines, similar to the lines that you see in the books. So voltage has been now filtered because we have a filter capacitor. That is exactly what you see here now. So when you put the filter capacitor, you take away the pulsations, the pulses. So the signal becomes closer and closer to a straight line. Remember, with DC, we are looking for a straight line. 12 volts voltage regulator. We are taking our signal from the output. As you can see, the probes that we have here. This is ground, that is from 12 volts. Now let's go back to the oscilloscope and see what we have. You see now the signal is far better as compared to what we had previously. It's getting closer and closer to a straight line. It's almost a straight line now.